So we're still working with our same standard, working with standard 3, and specifically today, we are looking at mole to mole. So we will see later in this week how these concepts come together to create something much, much bigger. So I know some of the things that I'm going to ask y'all to do right now seems a little tedious and a little redundant, but it makes your life much, much better as you are moving forward in the content, and it makes it so that you're less likely to make mistakes. So today we are actually looking at this last equation that is on our formula sheet with the stoichiometry concepts, and it's mole A equals mole B. And you'll notice that it has blanks in there instead of numbers. And those blanks are there to kind of remind you to look at your coefficients. Because when you're converting between substances, you have to take into account the ratio of atoms or molecules of one substance to another, and that's where those coefficients come into play. So I've used this term already before, stoichiometry, and I said, it's just kind of a fancy way of saying chemical calculations. And really it is. It just gives you quantitative information about a chemical reaction. Think of it like a recipe. So those of you who are in my culinary programs, you've seen recipes where you're trying to make some cookies or brownies or whatnot. And if you have to have more cookies or brownies, you end up having to have more ingredients. Same idea with stoichiometry. So my non-chemistry example is a turkey sandwich. So when I make a turkey sandwich, I always have 2 pieces of bread and 3 pieces of turkey and 2 pieces of cheese. I love cheese on my sandwich. Whatever condiments you want, just kind of include that. But all of those things together come together to form one turkey sandwich. The thing about stoichiometry is it tells me that in order to make 10 sandwiches, I got to have 20 pieces of bread. And in order to make 10 sandwiches, I need 30 pieces of turkey. Conversely, I could go between the turkey and the bread. If I know I want to make 50 sandwiches, I need 25 pieces of bread and whatever, 25 times 75. There we go. Mental math early in the morning. 75 pieces of turkey. So this is the information that stoichiometry provides us. Now, that is looking at pieces of one thing to another. So think of that as the equivalent of looking at a mole of one substance to a mole of another substance. Their units are the same. Now, in chemistry, we have to have that balanced equation in order to do these stoichiometric calculations. Yesterday, notice we didn't really talk much about that balanced equation because we were just learning how to get to and from the moles. But now that we've seen how to get to moles, now we've got to learn how to switch between substances. Now, the thing is if I don't give you that balanced equation, you're going to have to balance. So we learned in the previous unit how to balance, and you will see balancing again on the upcoming quizzes and assessments. So if you're struggling with it, make certain you reach out to me in one of the breakout sessions or in tutorial. So some terminology, just so that we're all speaking the same language here. A mole ratio. It's the conversion factor that we derive from the coefficients. So if I use the example before for my turkey sandwiches, I have 2 breads equals 1 sandwich. Or 2 breads equals 3 pieces of turkey. So the mole ratio gives us the relationship between the moles of any 2 things in the reaction. Now I use A and B. A indicates whatever you're starting with, and B represents what you're ending with. So if you prefer replacing those variables with the words to kind of remind you that you have to take into account the mole of the substance you start with and the mole of the substance that you end with. Other things that are in the problem don't come into play. So, if I'm back to my turkey sandwich, if I'm trying to make sandwiches and I'm only thinking about how much cheese I need to buy, then it's the sandwiches and the cheese that are important. I assume that I've got plenty of bread. It's coming out my ears. I got plenty of turkey. I'm good to go. Now, if those mole ratios can be between any 2 things, so between 2 reactants, 2 products, product and a reactant and a product. But the key here is that they all have to be in moles. So if I don't give you moles, you would have to convert to moles. Now, for today's lesson, we're working with strictly things that are already in moles. We're just converting between two different substances. I cannot stress this enough that the mole ratio is the only time that the coefficients come into play. Any other time in any other conversion, your mole is always a 1. But anytime you're switching between two different substances, you have to have it in moles and you have to use the coefficients. So remember that if there's not a number in front of a substance in the balanced equation, it's an understood 1, which means we have one of those substances. So mole conversions are really no different than what we saw yesterday. There is that added step of if I don't have the balanced equation, I have to balance it. We use our same dimensional analysis setup. So the first thing that's got to hit the page is the number in the problem. You write your given number, its unit, its chemical formula. And then you're going to multiply by a fraction. That fraction piece is the key to dimensional analysis. So when we're setting up the fraction, the unit that we start with, that unit and chemical formula has to go in the bottom. So let's say I'm starting with 12 pieces of bread. So for this analogy, 12 moles of bread. And I want to know how many things of turkey I need to make my sandwiches. So the first thing I've got to write is the 12 moles of bread. I multiply by my fraction bar. The unit and the substance that I started with goes on bottom, and the unit and the substance of what I'm going to goes on top. Once I put the units in their place, then you fill in your numbers. So you fill in your numbers after you figure out what goes where. Well, think back to my balanced equation that I showed you guys earlier. I had 2 pieces of bread, and I need 3 pieces of turkey in order to make 1 sandwich. This is the same type of calculation you would be doing, but instead of with turkey and bread, you're looking at it with your compounds, your substances. So type this into my handy dandy calculator. And my calculator tells me that I need 18 moles of turkey. So for this analogy, in order to make and use up all of my bread, I need 18 pieces of turkey. Now, a couple of things that I did notice looking at some of the practice y'all did yesterday. First and foremost, the number that I give you in the problem is never, ever, ever going to go in that conversion fraction. It always goes at the very, very beginning. Additionally, you're going to want to make certain that you have not only the unit, but the chemical formula. Now, those of you who actually do remember this from your freshman math class, your math teacher might have shown it a little bit differently, and I'm not one to get tied down in the little details. So I'm going to rewrite this as some of the math teachers show, and they use what's called train tracks. And instead of showing little bitty individual fractions, they put it all together, but the process is still the same. Got to start with what my number is from the problem. The thing that I'm getting rid of goes on bottom. I'm getting rid of bread. The thing that I'm going to goes on top. I'm going to turkey. And when I'm filling in my conversions, I have to look at my equality statements. And remember, this one is blank mole A to blank mole B to remind me to look at my coefficients. So 2 breads, 3 turkeys, handy dandy calculator, 18 moles of turkey. So though they might look different to you, it's the same exact information. So if you prefer using the blue setup, it's fine. It doesn't matter. You're still using dimensional analysis. It looks a little bit different. What you can't do is just have the numbers 12, 3, and 2. Because chemistry is not just about the numbers, it's also about the units and the formulas. So I need to not only see what the numbers are doing, but I also need to see what unit is coming and going and what substance you're playing with. So let's look at a first example. And this particular example, I'm giving you the word equation. thinking final exam, you could, in theory, see something like this where I'm not giving you a lot of information. For our unit test, I'm leaning more towards, I'm going to give you the equation, you might have to balance it, but I'm not going to ask y'all to have to go from the words to the letters, balance it, and then do some math. So that's my skeleton equation, and it's not balanced because I can easily see that my nitrogens don't balance. So if I go through and I balance it, I see that I need to have 2 ammonias for 1 nitrogen and 3 hydrogens. So now that I've got that balanced equation, I can actually do the math. I'm looking at my problem, and one strategy that you can use to help you is to highlight or underline your unit and your numbers. Because the thing that has the number is what you're starting with. Whether that number is at the beginning of the problem, the middle of the problem, or the end of the problem, you got to start with your number. So I'm going to write my 3.45 moles of NH3, because that's my number in the problem. I'm going to multiply it by a fraction bar. Since I started with moles of NH3, it's got to go on bottom, because what I'm getting rid of always goes on bottom. For this problem, I'm trying to go to find the other unit, moles of hydrogen. So moles of H go on top. That means for this problem, I am only focused on these 2 pieces of the equation. My coefficients have to go beside their substance. So NH3 is going to get a 2, H2 gets a 3. And I type this into my calculator, and I know we haven't talked much about a calculator, but guys, if you don't have a calculator with a fraction button, I would encourage you to use the Desmos, because it makes the math mistake-proof. You can quite literally type in exactly what you see. And my calculator tells me that I need 5.175 moles of hydrogen. My honors students, we are looking at significant figures, which short explanation is the number of numbers you start with needs to be the number of numbers you end with. So technically, my honor students, I would prefer y'all to have 5.18 mole hydrogen. General kids, guys, just give me several numbers. As long as it's not a really, really tiny number, usually 2 numbers after the decimal is sufficient to get you where you need to be. Y'all are going to have, range of acceptable answers. So something like 5.2 or 5.17 or 5.175, they're all fine. But my honors kids, we are looking at significant figures, and I will talk more on that with you guys live on Wednesday. So let's look at a second example. Bad misreads. So different reaction. Notice this reaction is already balanced. I've got coefficients. So assume that if Ms. Rains is giving you coefficients, that she knows what she did and she gave you the right coefficients. There's nothing in front of that aluminum sulfide. So it's an invisible 1. Feel free to fill it in if you need it. So looking at my example number 2, find the number, find the unit. That tells you what you got to start with. So first thing I do is I write my given number, its unit, which is moles, and the substance. I multiply by a fraction. What I'm starting with, that same unit and substance, has to go on bottom. Now I'm going to reread the problem and figure out what I'm going to. So it's asking for moles of Na3P. Since I'm asking for moles of sodium phosphate, that means that has to be what I'm going to. So my balanced equation tells me that for number 2, I am focusing on the 3 moles and the 2 moles that I just circled in blue. So 3 has to go on bottom because it is the substance I'm starting with. 2 has to go on top because it's the substance I'm going to. And my answer should have 4 numbers. So 48.33, because we started with 4 numbers, moles of Na3P. So I'm showing my math using dimensional analysis. This is dimensional analysis. I've got my numbers, my units, and my formulas each step of the way. I know right now it seems a little redundant, but when we get to the multi-step problems later in the week, it'll be much easier to not lose track of what you're going to or between if you know what exactly you're working with. So that's why I'm so adamant about writing the units and the formulas. So example number 3. And guys, I don't want y'all to get up with the fact that both of these examples, the numbers at the beginning. I could reword the equation and say, how many moles of ALP were produced from 14.45 moles of aluminum sulfide. So it doesn't matter where the number is, the number has to be what I start with. So looking at my example number 3, this has got to be what I start with because it's got the number. So I'll write down the number from the problem, its unit, its chemical formula, times a fraction bar. What I'm getting rid of goes on bottom. What I'm going to goes on top every single time. So the unit that I started with is what I'm trying to get rid of. It's got to go on bottom. The unit that I'm going to has to go on top. I look at my balanced equation, and for this one, I am focused on the aluminum sulfide and the aluminum phosphide, and I'm going from product to reactant, which is fine. So I'm going to put that 1 on bottom because there wasn't a number in front of that last substance. So it's an understood 1. And on top, I'm going to put my 2 because the 2 is the coefficient for my aluminum phosphate. And handy dandy calculator gives me 28.9. But my honor students, remember you got to have the same number of numbers you started with. So my calculator gave me 28.9. I'm going to write 28.90 moles of ALP. So if you've been following along, pause the video in just a moment once you see the last example, give it a try, and then unpause and see if you've actually gotten it correct. So this is my last example for today, and it is looking at each product, and I will be nice and go ahead and give y'all the balanced equation so that you don't have to worry with that. 2, 1, and 3. So pause the video now and set up the conversions for example number 4. All right, welcome back. Hopefully you actually paused the video and gave it an attempt. If you did, you would have noticed that you are going to have to do 2 calculations. So I'm asking you 2 different questions. I'm asking you to go from Na3 to NH3, ammonium, to nitrogen, and I'm also asking you to go from ammonia to hydrogen. So the process is the same. We still start with what is given to us in the problem. So for my first calculation, I got to start with that 6.5 moles. Notice my fraction, I've got 2 moles on bottom because NH3 is what I started with. It's got to go on bottom, and its coefficient is a 2. So I just chose to do nitrogen first. It really and truly doesn't matter because it's asking for each product. So you would have to do 2 calculations to go from the ammonia to both the nitrogen and the hydrogen. Notice my second fraction looks a little different because the product, the thing that we're going to, happens to be different. We're going to hydrogen. So the number on top is a 3 because my coefficient for my hydrogen is a 3. That is it for today. As always, I am going to be in the Meet for those of you who need assistance, and I'll also have the breakout rooms open today for those who just want to pop in and ask some clarifying questions. Hope y'all have a fabulous day, and we are going to kind of combine Monday and Tuesday stuff together later in the week.